it's not morning for you, but it's morning for me. So what did Einstein refer to as the greatest force on Earth? Well, that would be compound interest. So chapter 13, we're going to take a look at simple and compound interest, which if you have a bank account, or if you have school loans or any type of credit card debt, you know about compound interest. Okay, so in some loans, interest is computed just once during the life of the loan, and that's using simple interest. And other loans, they'll compute your interest more than once during the loan, so oftentimes it's once a month or something along those lines. And interest is added to the principal, which is the original amount, and then the new amount becomes the new principal for the next interest calculation. So month 1 you build on the principal, month 2 you build on what you've already built on. So you're continuing to grow and grow and grow faster and faster and faster. So it's an exponential growth, and that process is compound interest. So there's the good, the bad, and the ugly of compound interest. It's good if it's working for you. So for example, with a savings account, you're gaining interest on top of interest, which can be really good, especially if you have more money to invest. However, with school loans and debt, then it's building on top of what you've already built on, and you can end up owing a lot more money in a short amount of time than you ever expected. So make sure you pay off your credit cards right away. Some interest rates I was looking at. So for, just take Bank of America for example, a regular savings account, the interest rate is 0.01%. So that's why you may not see much interest if you have a regular savings account. You may see a couple pennies. Their money market account is a little bit more, but really not anything, because really then you'd be multiplying by, if you move the decimal over twice, be multiplying by 0.0003, so it's not a significant amount. CDs, which are certificates of deposits, not the musical CDs. What a CD is, if you aren't aware, it's basically an account where you can put your money for an extended amount of time, but you can't touch your money for that period of time. So they have CDs that could be anywhere from like 6 months to 10 years. So like I used to have a CD that was for 6 months. And the advantage is that it gains more interest. You can get a higher interest rate, but you're not allowed to touch that money for 6 months or whatever the life of the CD is. And if you do get that money, you're charged a penalty. So the longer you leave your money in, the higher the interest rate you can get. Also, the more money you put in the CD, the higher the interest rate you can get. So that one with like a bunch of money and for doing it for 10 years, the highest interest rate is 0.15%. So it's better than 0.03, but still not significant, right? There are some different interest rates that you can look at online. I've heard that Capital One has a high interest rate if you're trying to do a savings account. And there's another site you can go to if you would like to check out some different interest rates of where to invest your money. So compare this, money working for you, to money working against you. School loans, on average, have an interest rate of 3.76%. So 3% versus 0.03%, that's significant. So you're going to accrue more interest here than you're going to gain in your savings account. So so try and pay those off as quickly as possible. Okay, here's an example from that Dave Ramsey gives a lot of times. If you've heard of him, he's a financial guru. He's on the radio, and he started Financial Peace University. So Ben and Arthur were friends who grew up together. They both knew that they needed to start thinking about the future. Well, when they were 19, Ben decided to invest $2,000 for every year, and he did this for 8 years. He found investment funds that averaged a 12% interest rate. That's very hard to find, but according to Dave Ramsey, you can find it using mutual funds and things like that. So then at age 26, Ben stopped putting money into his investments. So he did it for 8 years, and then he just didn't put any more money in. And then he just let his money work for him. So he let the interest accrue. So really, over time, he only ended up putting $16,000 into his investment funds and then just watched his money grow. Arthur, his good buddy, did not start investing until age 27. So after Ben was done investing. But like Ben, he also put $2,000 into his investment funds every year until he turned 65. He got the same interest rate, but he invested his money 23 more years than Ben did, because he did it every year until he was 65. So $2,000 every year from 27 to 65. So he ended up investing $78,000 of his money over 39 years. Ben only invested $16,000 over 8 years. So when they turned 65, who do you think had more money? And it's actually quite surprising. Ben, so here's what Ben's looked like. $2,000 and then nothing after that. But his money kept growing in that account. He ended with $2,288,996. Arthur, who waited until he was 27 to invest, but then look at how much money he invested. Wow, he ended up with significantly less than Ben did. So, moral of the story, invest early. So the earlier you can invest, if you can start investing now, and then just watch your money work for you, you're going to have a lot more money at retirement age than if you wait. It's never too soon to start investing. Okay, future value is the amount you're going to have in the future. So it's sometimes called the maturity value or the compound amount. And there are two ways to solve for the future value. You can use a formula that I'm going to show you, or you can use the future value table. So the formula, there are a couple formulas. This is for simple interest. So to find the simple interest, this is when it's just taken once throughout the life of the loan, or if it's not a loan, throughout the life of the account. All it is the principal, which is the initial amount, so how much you invested, times the interest rate. Now make sure that the interest rate is a decimal when you plug it in here. So from here on out, anytime you plug in the interest rate, make sure it's as a decimal. And then T is the time that you've invested. So the period interest rate would be the annual interest rate divided by the number of periods. So for example, let's say you have an annual interest rate of 12%, but you want the monthly interest rate, then you just take the 12% and divide it by 12, because you're going to do this 12 times if it's monthly, because there are 12 months in a year. So 12% divided by 12 would be 1%. So that means every period, so every time they calculate the value of your loan, they're going to take 1%. So that's for later. Now, the formula your book gives for compound interest is this one. FV means future value. P means the principal, so the initial amount. This is a 1, not an I. I know it looks like this one, so that can be confusing. That's a 1. This is the period interest rate, which you find by taking the annual interest rate divided by the number of periods. And then this capital N is the number of times compounded total. Well, if you're compounding for 3 years, but you're compounding monthly, this number is going to be 3 times 12, 36 times, because you're compounding a total of 36 times if you do it every month for 3 years. So I don't really like this formula, because I have to think about calculating the interest rate, and I have to think about calculating the total number of periods. So I prefer this formula that I've written here for you, which says the same thing. I've just basically helped you figure out the period interest rate and the total number of times compounded by giving you this. So this again is the initial amount. We've got over 1 here. R, so I've written down here, is the interest rate as a decimal, so make sure you convert it to a decimal. N is the number of times compounded per year. So if you are doing monthly, that means it would be 12. If you are doing, let's say, quarterly, that means you would compound 4 times a year. If you did semi-annually, that'd be twice a year. So that'd be 2. Daily should be strange. I've never heard of an account doing that, but that'd be 365 times a year. Weekly, there are 52 weeks in a year, so it'd be 52. Now, whatever number you put in here is the same number you put in there. And then NT means N times T, so those are being multiplied. And T is the time in years. So if you're compounding monthly for 7 years, T would be 7. Okay, and that's all listed here. All right, so find the future value of a loan of $800 at 13% for 3 years. All right, so FV equals, if you look back, oops, too far. So there's simple interest, there's compound interest, but let's just think about just doing it simply. So if you do the principal, so simple interest, principal, times rate times time. So for simple interest, we'll come down here first. Let's do this first. You get the principal, which is 800, times the rate, which is 0.13, because this is your R. You need to convert to a decimal, times the time in years, which is 3 years. So if you plug that into your calculator, you get, sorry, let me get that here for you, 800 times 0.13 times 3, you get $312. Okay, so now let's look at compound interest. The reason I'm skipping A is because the future value is going to be different depending on if you do compound or simple interest. So for compound interest, we're going to use the other formula. Now, notice this formula calculates the future value. So once I get the future value, I can figure out how much interest was gained to get from the original value to the future value. So I'm actually going to use this one instead because I like that one better. So for compound interest, I am going to take the principal, which is 800, times 1, so that's a 1, plus the interest rate, which is 0.13, divided by n. So n is the number of times compounded in 1 year. Well, they didn't say anything about compounding other than once a year, so I'm just going to put in a 1 for now. And then up here, be 1 times the number of years, which is 3. So I'm going to show you how to plug this into Desmos if you haven't used Desmos before. So if you go to desmos.com, it's a graphing calculator. It's really nice because you can just plug it right in here. 800, and then in parentheses, 1 plus 0.13. Now to get it over a number, you push divided by, so the little slash symbol, 1, which I don't really need to write that. And then to raise it to a power, if you go to the little keyboard here, this is to square it, this is to raise it to any power, so I'm just going to raise it to any power. And then up here, I'll put the 1 times 3. And you can either put in parentheses, or you could do the symbol, the little asterisk symbol, which would be times. So it's going to be $1,154.32. I'm going to round this one up because the 7 is higher than 5. 1154.32. Okay, so 1154.32. All right, so this is not the compound interest, this is the future value. So to figure out how much compound interest, I'm going to subtract those two. So I will subtract the original amount, which was 800, and that gives me $354.32. All right, so this amount, that's the amount of compound interest. This was the amount of simple interest. So it's always going to be better. You're always going to have more money. Well, I guess it could be better or worse depending on if it's working for you or against you. But you're going to have more interest if you do compound interest versus simple interest, because you're compounding more often and you're building on what you've already built on. So what's the difference between the two? So basically, how much more are you going to get from compound interest than from simple interest? You'll just subtract the two numbers. So that's going to give you $42.32. All right. Questions on that? I don't know why I just asked you that, because you can't answer me. I'm so used to asking that. Okay. So let's look at some school loans. The average debt per graduate from school loans in 2018 was $37,172. So that's average. So some people might have had none, some people might have had significantly more than that. The annual interest rate for most school loans is about 4.5%. Or at least it was in 2018. Calculate the future value of the loan after 10 years if interest is compounded monthly. So, since it's compound interest, I'm going to use this formula. Future value is P. Now sometimes you'll see P written as PV, which is the present value. So, just so that you are familiar with that. Okay, so the initial amount is $37,172. So that's how much they have in loans before interest is calculated. Okay. And then the rate is 4.5%, so I need to move the decimal over twice, giving me 0.045. And then the number of times it's compounded in a year. So monthly is usually what it is. If you think about just your bills are sent monthly, so it's the interest is paid monthly typically. So that's 12 times a year. And then up here I'm going to have 12 times the number of years. T is the number of years, so 10 years. And this is going to give us the amount of how much we're going to owe after 10 years. And this is if we didn't pay back anything over those 10 years. So if you plug that into your calculator, let me just do that here for us. It's going to be quite a bit. So it's always better to pay your loans as quickly as you can. You end up getting $58,000. $58,000 $58,248.26. So you end up owing like $20,000 more just in interest. So that's why it's super important to pay it back as soon as you can. Put more on your payment than they ask you to, because their minimum amount is not going to make a dent. So how much interest did you end up paying? To figure that out, you'll just take the future value, so how much it will be worth in 10 years, and you'll subtract what it originally was, which was the $37,172. And you get $21,076.26. You can get another degree for that, huh? Well, part of a degree. All right. So the other way to do this is to use the $1 future value table. It's on page 473 of your book. I also typically attach it in an announcement, or it might be in the files. But when you're doing your homework, it should pop up if you need it. So you'll notice the table is based on the period interest rate, which is the capital R. So if you want the interest rate, you're going to have to use this formula. So if it's a monthly interest rate or a quarterly interest rate, you're going to have to divide the rate by how many times you would compound it in a year. And then for the number of periods on the table, it means the total number of times that it's compounded. So if it's compounded monthly for 3 years, you're going to have to do n times t, 12 times 3, to get the number of periods. So number of periods is the total number of times you compound it over the full life of the loan, or whatever it is. Okay, so to find the future value using this table, you're going to take the principal value and multiply by the table number that you get. So, I know this is kind of hard to read, but it is in your book. So notice the periods here, this column. That's the total number of periods, so that's n times t. The rate per period, so you're going to have to do n, the annual interest rate divided by t. R divided by n, the annual interest rate divided by the number of times you compound. So notice here is 0.5%, 1%, etc., and then it picks up at 6%. So this kind of starts the table all over again. So, for example, there we go. That's a little bit easier to see. So on this problem, actually no, we'll do a new problem. Okay, so I want to buy a penguin, but apparently it is illegal. Seriously, I checked. But instead you can adopt one from the zoo, which I guess means you can go visit it anytime. I'm not quite sure about that. But I'm going to need to save up some money. So I have $3,000 right now, and I plan to save for 10 years, compounded semi-annually, which means twice a year. Semi means half. Think about a semi-truck. It's like half a truck, or the semi-annual clearance sale at Bath & Body Works, right? Twice a year. So 2 times a year with a 6% interest rate. Will I have enough money in 10 years if a penguin costs $5,500 to adopt? So using the table, first thing I need to basically figure out the number of periods and then the interest rate. So the total number of periods, well, I'm doing it for 10 years, but I'm doing it twice a year. So it's 10 times 2. It's that n times t. And here I put t times n, right? N would be 2, t would be 10. And then for the interest rate, I'm going to have to take the annual interest rate and divide it by the number of periods, or the number of times I compound in a year. So this is a 6% annual interest rate. So I'm going to need to take the 6% as a decimal, which is actually. If you notice on the table, the interest rates are written as percents, so you don't need to convert that. So 6% divided by the number of times I'm doing it a year, which would be twice. So the interest rate is a 3% interest rate every time you compound. If I had been doing it monthly, I would divide the 6% by 12. If I had been doing it quarterly, I'd divide the 6% by 4. But since I'm doing it twice a year, I'm going to divide it by 2. All right, so basically I'm going to look at my chart for, this was 20 periods at 3%. So 3% is right here. 20 periods is right there. So if I follow that over, the number on my table is 1.80611. And to calculate the interest, I'm just going to, or the future value, I'm just going to take this number on the table times the original value. So I had $3,000 originally. So that's like my present value, my principal. I'm going to multiply that by 1.80611. So if I do that, please, please, please have enough money to buy my penguin. $5,418.33. Wah, wah. All right, so I don't have enough money to adopt a penguin. So, but if one of you would lend me some money, I'll let you have visiting rights. All right, so that's how you would calculate it using the table. If you wanted to calculate it using the formula, you could do the P is 3,000, 1 plus the interest rate, which is 0.06, divided by n, the number of times compounded in a year, to the n times t, so 2 times 10. And if you plug that into your calculator, let's just see what you would get. Oops. You get the exact same thing. So either one will work. And sometimes you'll be a couple cents off if you use the table versus using the formula, but that's no big deal. All right. So let's say you purchase an HTC Vive on a whim. On the website, the bundle costs $800. Since you don't have $800 lying around, you decide to get a credit card to pay for it. You find a popular credit card that has a monthly interest rate of 12%. If you don't make any payments for 2 years, how much will you owe? So this I actually did find on a website. And this is, I found this on a website as well. This was a popular credit card. Excuse me. With an annual interest rate. This one has 14.49%. We're going to use 12% so that we can potentially use the table. So if I wanted to use the table, I need the number of periods, and I need the interest rate, the period interest rate, right? So the number of periods, I'm doing this for 2 years, and it's a monthly interest rate, so I'm going to do times monthly is times 12, right? So I have 24 periods. The interest rate is going to be the 12%, but I'm doing it monthly. So this should have been an annual interest rate that they calculated monthly. So that gives me 1% each time it's compounded. So if I look on my chart for 1%, it's going to be right here. 24 times is right here, so 1.26973. And then I multiply that by the original amount, whatever number I got from the table. And if you do that, 800 times 1.26973, I get $1,015.78. And With money, you'll always round to 2 decimal places. So notice I ended up paying over $200 extra just because I couldn't wait and I wanted to buy it now. So be very careful about credit cards. If I had used the formula, the 800 would go here. I'd have 1 plus the rate, which is 0.12. So when you put it in the table, do make sure that you convert it to a decimal. Whereas for using the future value table, you didn't necessarily need it, but with the formula you do. And then divided by the number of times compounded in a year, which is 12, and then raise it to the 12 times 2. And you should get about the same thing. All right. Now, to find the present value. So let's say you want to know how much do I have to invest now to have some amount in the future. So all it is it's taking this formula that we had before. So instead of P, I'm going to put PV for present value. That's the same as the principal or the initial. And all you do is you solve backwards to get PV. So to get PV alone, this is being multiplied by this whole thing. So I'm just going to move that over by dividing by that whole thing. Which gives me this formula, or actually more likely this one with the adjustments I've made to the formula. So this formula just came from rewriting the future value formula. All right, so I wonder if any of you know this. What percent of the house price is recommended for you to put down as a down payment on a house? Drum roll. The answer is 20%. So yay if you got it right. It is so that you don't have to take out a private mortgage insurance. If it's anything less than 20%, you have to take out an additional mortgage insurance. Okay, so let's say you want to put a down payment of $20,000 on a house. So I want to know how much money would you have to invest now for 5 years at 6% paid quarterly in order to have that kind of money. So if I want to know how much money I need now, that means I want to know the present value. And this is the amount of money I want to have in the future, so that is the future value. This is going to be my time in years. This is going to be my interest rate. Quarterly is going to be the number of times I'm compounding. So since I'm solving for the present value, I'm going to use this formula right here. So I've got present value equals future value divided by 1 plus r over n to the nt power. The future value is going to be 20,000. The rate is going to be 0.06. The number of times compounded is going to be 4 because quarterly means 4 times a year. Think of 4 quarters in $1. And then whatever n I put here is the same n I put there. And time in years is going to be 5 years. So if I plug that into my calculator, and I usually use Desmos because otherwise you have to do it a piece at a time. So you'd have to do these two divided, and then added to 1, and then raised to the 20th power. So there's less room for error if you use Desmos. Plus you can see exactly what you've written out. So I highly recommend Desmos. If you don't know, there is an app as well that you can download for Desmos. It's totally free. So there's like a mobile edition. But anyway, when you do this, you get $14,849.41. So if you want to have $20,000 in 5 years with this interest rate and this number of times compounded, you need to invest this much money right now. So that's the present value. If you don't have this amount right now, then you either need to find out something with a higher interest rate or you need to be able to invest longer. Okay, calculate the present value using the table. Okay, so here's the table for that. That will also pop up if you need it on the homework problems. So here, you'll multiply the principal by the appropriate value in the table. Or I guess it's more of the future value, it should say. So if I want to have, I'm going to change this to future value. If I want to have 20,000 in the future, that means I need to know the number of periods. So remember, that is the total number of periods. So that's however many years you're doing it times the number of times you're doing it every year. So we were doing it quarterly for 5 years. So a total number of periods is 20. And then the rate per period, so it was 6% was the rate, but per period I'm going to have to do R divided by N. So divided by the number of times I'm compounding in a year. So that gives me 1.5% each time I compound. So 1.5% for 20 years is 0.74247. 74247. And if you multiply those in your calculator, 74247, you get $14,849.40. So if you look at the difference, it's 1 penny off, right? So you'll get a very similar answer if you use the table or if you use the formula. Some of the questions might ask you specifically to use the formula. Some of the questions might specifically ask you to use the table. In that case, the table would pop up as an option. But if you don't, if you're not given that instruction, you can pick which one you want. Okay, this could change depending on the person. So if you wanted to figure out how much you would have by retirement age, how to get $1 million, you could use that formula. Okay, and we're not going to do that. Okay, so the effective interest rate. You may see this called the APY, annual percentage yield. And it's basically the equivalent simple interest rate that's equivalent to a compound rate. So if you could break it down into just being applied once throughout the loan, it would be what would be the simple interest rate based on all the compounding that took place. So you may have seen these letters APR, you may have seen APY. So sometimes they'll disguise a loan as having a lower rate for obvious reason. They want you to think you're getting a lower rate when you're really not, because then you're more likely to buy it. And the way they do this is they quote the APR. So that's the annual percentage rate. This is the APY is the annual percentage yield. So APR does not take into account the compounding, whereas APY does. So all the APR it's the periodic rate of interest multiplied by the number of periods in the year. So, for example, for credit card charges interest of 1% each month, the APR is 1% times 12, because 12 times a year. So they'll say the annual percentage rate is 12%. However, if you were to calculate the amount of interest and then divide it by a month and figure out the real rate that you're being charged, it ends up being 12.68%. So it's actually a little higher than the APR, but they'll quote you the APR instead of the APY, whereas APY is more realistic. So, Marcia borrowed $600 at 10% compounded semi-annually, so twice a year. what is the effective interest rate? So what is the APY? It's the same question. So to do that, you first have to figure out the period rate interest, so the period interest rate. So 10%, so that's your whole R divided by the number of periods, so R over N. So 10% is your annual interest rate, and you're doing it semi-annually, so N is 2, R is 10%, right? So if you divide that, you get 5% or 0.05. Now, if you had wanted to convert this first to 0.10 and then divide by 2, you still get 0.05, right? Just make sure at some point you do convert it from percent to decimal. So the compound interest at the end of the first year, so if you calculated that, perhaps you use the formula, you would take the future value is going to equal the present value, or P times 1 plus R over N to the NT. So if the present value right now is $600. The interest rate was 0.10 twice a year, and then you're doing it twice a year for 1 year, because the end of the first year. And if you do that, you end up getting $661.50. So the amount of interest you earn during that first year is $61.50, because this is how much you ended with. You had started with $600, so if you subtract them and find the difference, you're left with $61.50. So if you want the annual effective interest rate, you're going to take the amount of interest and divide it by the present value, by the original amount, the principal. So $61.50 divided by $600. You do that, you get 0.1025, or as a percentage, 10.25%. So you actually end up paying 10.25% when all is said and done, and they probably quoted you at 10%. So this is the annual effective interest rate. So this is taking into account the compounding. Okay, and that will conclude chapter 13. Good luck on your homework, and if you have any questions, as always, please feel free to email me.